Hello, everyone. Today, we will begin studying synchronous generators. In this lesson, we will introduce the basic concepts of synchronous generators. Synchronous machines are a type of AC rotating machine. They are named because their rotor speed is always the same as the speed of the stator's rotating magnetic field. Synchronous machines are mainly used as generators. Synchronous generators convert mechanical energy into electrical energy. They are the main equipment for modern power generation. 1. Basic working principle of synchronous generators. The basic structural components of a synchronous generator include the stator, the core, the stator's three-phase symmetrical windings, the rotor core, and excitation windings. The basic working principle of a synchronous generator is the rotor excitation winding of the synchronous generator is supplied with direct current, and the excitation rotor immediately establishes a constant magnetic field. When the prime mover drives the rotor to rotate at speed n, its stator windings cut through the magnetic field to produce an AC induced electromotive force. If the synchronous generator is connected to a load, three-phase current will flow under the influence of the potential. This indicates that the synchronous generator has converted mechanical energy into electrical energy. The frequency of this electromotive force is F equals Pn over 60, where P is the number of per pulse of the machine and N is the rotor speed in revolutions per minute. The unit is revolutions per minute, RPM. If F is 50 Hz, P equals 1, and the rotor speed N equals 3000 RPM. If F is 50 Hz, P equals 2, and N equals 1500 RPM. The adjustment of the frequency P is the rotor speed N increases, the speed of the rotating magnetic field N increases, and the frequency of the stator's three-phase symmetrical voltage F increases. When there is a change, the input power and the driving force are adjusted in time to keep N constant. Thus, F remains unchanged. The rotor speed N increases. The excitation current IF increases. The speed of the rotating magnetic field N increases. The magnetic flux density B increases. The frequency of the stator's three-phase symmetrical voltage F increases, and the electromotive force increases. 2. Nameplate of the synchronous generator. The nameplate is attached to the housing of the synchronous generator. Is provided by the manufacturer to inform users of the characteristics and rated data of the machine. It usually includes the model, rated values, installation class, and other information. 1. Model. The model numbers of generators produced in China consist of capital letters of the pinyin alphabet and numbers. For example, the model of a steam turbine generator is QFSN 302. It means QF stands for steam turbine generator. SN stands for water hydrogen cooling, indicating the cooling method as water hydrogen. 300 indicates the rated active power output of the generator in megawatts. 2 indicates the number of poles of the generator. Another example is a hydro generator with model number TS900-135. 5-6. It means T stands for synchronous, S stands for hydro generator. 900 indicates the outer diameter of the stator core in centimeters. 135 indicates the length of the stator core in centimeters. 5-6 indicates the number of poles. 2. Rated values. 1. Rated power PN refers to the output power of the generator under rated operating conditions in kilovolts or megawatts. 2. Rated voltage UN refers to the rated line voltage on the stator's 3-phase windings under the rated operating conditions specified by the manufacturer in volts or kilovolts. 3. Rated current IN refers to the line currents flowing through the stator windings under rated operating conditions in amperes. 4. Rated power factor cosine phi N refers to the power factor of the generator under rated operating conditions. 5. Rated speed refers to the synchronous speed of the generator in revolutions per minute. 6. Rated frequency FN. The standard industrial frequency in China is 50 Hz. The relationship between the rated values of a synchronous generator is Pn equals Sn cosine phi equals square root 3 Un times In cosine phi. Exercise 1. Explain the working principle of a synchronous generator. Answer. The working principle of a synchronous generator is: the rotor excitation winding of the synchronous generator is supplied with direct current, and the excitation rotor immediately establishes a constant magnetic field. When the prime mover drives the rotor to rotate at speed n, its stator windings cut through the magnetic field to produce an AC induced electromotive force if the synchronous generator is connected to a load. Three-phase current will flow under the influence of the potential. Thus indicates that the synchronous generator has converted mechanical energy into electrical energy. In this lesson, we introduced the working principle of synchronous generators and the nameplate of the synchronous generators. I hope everyone practice more after class to consolidate the knowledge from this lesson. That's all for this lesson. Thank you, everyone.